Let me teach you guys how to code in binary. Each CPU has its own instruction set architecture, or ISA for short. And the ISA is basically a catalog of instructions that a CPU can perform based off the binary sequence that it reads. We're going to be looking at the ISA of the LC3, which is one my professor made. So let's take this line of binary code, for example. Binary code has two components: the opcode and the operands. The opcode tells you what instruction you're doing, and the operands tell you what values you're using to execute that instruction. So going back to this line of binary, the first four digits represent the opcode. And if we look at the ISA for the LC3, we can see that 0001 means add. But what are we even adding? Well, that is where the rest of the sequence comes in. The next three bits are known as the destination register. A register is an extremely accessible short-term storage location stored in the CPU, and it is not the same as RAM. For our CPU, let's say we have 8 registers. The name destination register entails that we're going to store the result of our operation inside of this register. And if we look at the binary 000, that means 0. So register 0 is going to store the result of our addition. The next 3 bits represent another register. This time we have 001, which means register 1 is going to be the first operand of our addition. Now the next line is actually 000. When we check the ISA, we can see that there's 2 add instructions, and the differentiating factor between them is everything after bit 6. Our second operand can either be another register or an immediate value. But in our line of code, 000 means we're going to be using a second register. So the last 3 bits, 010, mean that our last operand is going to be whatever value is stored inside of register 2. So when we combine all that we just discussed, we can figure out that this line of code is adding the value inside of register 1 and register 2 and then storing it inside of register 0. And when you have a sequence of binary code, each line is stored at a specific address in memory. And your CPU has a program counter which keeps track of the next instruction. This particular sequence of code negates whatever value is in R0 and stores it at memory location X3004. Now follow me for more content.